Hello, hello. Welcome, everyone. So we're going to start the session now. Okay, welcome, everyone here and everyone online. So this is the first, this is the second session of the Starknet Basecamp. So yesterday we started the Starknet week. And so today we will have a session about the fundamentals of Starknet. So let me show you the menu for today. So today we will see why H.E.R. So H.E.R is the language that Starknet uses. So we will see why we are using this language. Then we will cover why Starknet. So why would we use Starknet? What is the purpose of Starknet? Then we will cover the smart wallet, which is a very important feature in Starknet. And then we will finish by a small test with 10 questions that will count in your Basecamp graduation. So at the end of the Basecamp, you will have graduation, and we will take into account your participation in the test. So yes, let's get started. So why H.E.R? So H.E.R is the language that is used in Starknet. Why did Starknet created a whole new language instead of just using, I don't know, an existing language? So H.E.R is solving a very specific problem. And to explain you this problem, I'm going to start with an example. So imagine you want to explore space. You're a scientist and you want to go in space. So you want to save fuel, you want to be efficient, you want to be optimized, you want to have like very specific computation, best targets, best day, best everything. You want to optimize. So your engineer creates a big algorithm, big Rust or any like a code that you like. Your engineers are working hard on the algorithm, but it's a lot of computation. It's very computationally heavy. So you will have to cooperate because you don't have the computation power to do it yourself. So let's say you want to cooperate, but in your country, you don't have the computation power. You don't have it. You need to collaborate with someone you don't necessarily trust. For example, a rival country. Why would you, I mean, imagine just that person has the computational requirement and you just don't. They have a simple computer, but you don't necessarily trust them. So you collaborate with them. Do you trust or do you not trust? So if you are using Rust, for example, you kind of have to trust them. So you send them the code, they will execute with their supercomputer and then give you a result. Okay, cool. Did they execute my algorithm? Did they execute a cheaper one? Did they execute something that's completely random? Or did they try to sabotage me? I have no way to answer any of those questions. I just have to trust them. So how do we solve this problem? Well, with H.E.R, you can have a trustless cooperation. So you can cooperate with them without trusting them, which is very nice. So basically, you will give them the code to execute. They will do their execution in their very powerful computers, and then they will send you the results, but also a proof. So the proof is a proof of computation. It proves the integrity of the computation. It proves that the computation is the one that you ask them to do. So that's what H.E.R is doing. So it's actually very general. It's actually a very general, it's solving a very general problem. It's not very specific to blockchain at its core. It's just proof of computational integrity. So it can be used in those sort of random examples. Okay, so yes, if the execution is intentionally or unintentionally modified, or if the execution is corrupted, if the execution is not doing the computation that you asked the computer to do, the proof will be invalid. Okay, so that's very interesting. So the feature in Cairo is that it enables verifiable computation. It runs on top of its own VM, its own virtual machine called the Cairo VM. It has a syntax inspired by Rust. It has a similar ownership model than Rust. So if you are used to Rust, it's actually very, very easy to start using Cairo. And like the more it's advanced, the more we make updates on Cairo, the more it looks like Rust. So it's strongly typed, it has straight, it has macro as Rust, and it can be used outside of Starknet. So Cairo is a Turing language, a Turing complete language, so it can be used for any computation. Also, you don't need to know zero knowledge. So underneath Cairo, you have zero knowledge that's abstracted for you. So Cairo is meant to be used as a programming language. You do the logic, you do the programming, and you don't have to actually know about because we are also live streaming the session. So okay, we are back. We are live again. So yes, so basically there is just a few extra rules that you use while coding that you need to know to use Cairo as a smart contract language. But yes, we will have a session about how to write smart contract in Cairo later this week. So so I'm not gonna go in the detail right now, but we will go in the detail very soon. Okay, so here is a contract interface, the signature of a contract, and then a little storage example, and then public method. So yes, Cairo can be used as a smart contract language. Okay, so why Cairo? Cairo enables verifiable computation. So it proves computation integrity. So so by that it means that you can know that your computation, you can trust your computation. So your computation wasn't done in another way that's what was intended. So it's respecting the code that you wanted to execute, basically. So you can also verify without re-executing. So that's a very core aspect for blockchain. It's also a powerful and flexible language because it's Turing complete, so you can do a lot of things with it and prevents cheating and malfunction, and it keeps a supercomputer honest. Okay. Now we will, if anyone has a question, we can have questions at any time, so don't hesitate. Okay, so why Starknet? So now I'm going to talk to you about the layer 1 scaling problem. So Starknet, as a layer 2, wants to scale the layer 1 Ethereum, and yes, that scaling Ethereum is a big challenge. So, for example, on Ethereum, when you have a new block that is introduced, it's introduced a lot of transaction, a lot of transactions that have been executed, and then it proposed a new state. Sorry. Pardon? I have some. Oops. Okay, so now there is this new block. All the validators, they have to redo all the computation to verify that the state is correct. So you do all the execution. You execute all the computation of the transaction, then you have a new state, you put it, you say this is a new state, everybody validates, everybody redo all the computation. And that's actually a lot of work. So it ends up with a lot of gas fees because you have to pay everybody for their computation. And yeah, that's a lot of redoing the same thing. So with this verifiable computation, you have a new system. So now you will compute the execution, and then you will have the new state, but you will also have a proof of computation. So you will compute the proof of your computation. That's actually a little bit of extra work for you, but then all the validators, they only have to verify your proof. And verifying your proof is actually much cheaper than doing the whole computation. So instead of redoing the whole computation, you just verify the proof. So as a small example of performance, you can see that executing the transaction is like, if it's linear, then computing their verification is the logarithm of that. So you have much better performance. You can see it on the graph as the number of computation step increase, the verification gets much more beneficial, and it's a much better choice. So and yes, also it says improve with proof recursion because there is a new there's going to be proof recursion soon on Starknet with a new prover, and it's going to be even more performance. So this is with what we have right now, but it's going to be even better soon because we work on like improving the proof generators. Okay, so let's talk a bit more about the proof. So the proof are called validity proof. It's a use case of zero knowledge proof. So it's not zero knowledge in itself, in the sense that there is no optimization for like privacy. It's more about computational optimization. So what it means is that the verifier will convince layer one that the computation it has done was correct, and without sharing too much detail. So without giving everything, without giving the whole detail, the whole computation, and they have to check everything, they give less. So yes, it doesn't make the layer two more private. It just makes the verification efficient, and it makes the execution on layer two cheaper. So the type of proof that Starknet is using are the Starks. So the Starks have actually been created by H.E.R, and now it's becoming a standard. But yes, they were the first one to use the Starks because it was their technology. So let's review the Starks. So there are Stars and Snarks, which are the two ZK proof that are the main one at the moment. So here we can see that Stark is like logarithm of n, Snark is a constant verification time. The proof size is like this, and the proof size is better for Snark. So why would we use Starks? Because it's more time to verify, and the proof size is bigger. Well, because it takes way less time to prove, it has no trusted setup, and it's quantum secure. So those features are super important. So the proving time actually matters a lot, because if you want to have use cases, you need to be able to verify it quickly, but you actually also need to prove it quickly. So the proving time is very important. Then the trusted setup, it doesn't require any private information that could leak. So that's also a very important feature for security. And then finally, quantum secure. If like quantum computer will not be able to crack Stark proofs, which is very important feature because we have to already plan for that and already be prepared. Okay, so this slide is getting maybe more and more irrelevant every day, but so far we have the H.E.R VM. So the H.E.R is executed by its own VM, and it's not a ZK EVM yet. So it's gonna be a ZK VM very soon, actually, because there's a project on Starknet that is like building ZK EVM for Starknet. So they are actually live on testnet. And the CEO, Elias, will make a talk later today. So you will know much more about ZK EVM and ZK EVM on Starknet. So I will not talk about this too much, but so far, Starknet has its own H.E.R VM for performance reasons. So basically, the EVM was created for regular architecture, not it wasn't optimized for ZK computation. And it's actually a very different kind of computation. And the H.E.R VM is optimized for those computation. And so it's very good for performance. Okay, let's talk about finality. So some measure of time. So here you have Ethereum. It takes a kind of sort of around 6 minutes to have the finality. On Ethereum, it takes about a week for optimistic rollups, which is a lot of time. So where is Starknet? It's like about 10 hours to settle on Ethereum, but it's only 2 seconds to be on layer 2. So it takes 2 seconds to be executed on layer 2 and about 10 hours to be on Ethereum, which is much better than a week for optimistic rollups. Okay, so let's summarize what we discussed. So Starknet is optimized for zero-knowledge technology, more precisely validity proof. So it's you can do much more heavier computation. Computation is much cheaper on Starknet, so you can do a lot of computation. You can do a lot of use cases that would require too much computation to do it on Ethereum, and it has very low gas fee. So during all the examples, you will see how cheap it is. When you go back to Ethereum, which Solène did yesterday, you are very like, wow, by the gas fee. You're like, oh, I got used to paying an amount of money that's so small, I don't even understand it. It's like a fraction of cents. So that's very cool. Then it's secured by the Stark technology, which is very strong, and Ethereum. It's using a very powerful programming language, H.E.R. It has been battle tested. So there has been more than $1 trillion in transaction in the past 2 years on Starknet. So there's been a lot of money involved, and yeah, so it has 2 years of battle tests, which is good. And then yes, you have if you want to withdraw your asset to layer 1, it takes 10 hours. And then finally, you don't have a trusted setup. So it's very good for security. Okay, so let's continue. Now I will be talking about the smart wallets. So smart wallets is a big feature on Starknet because unlike a lot of other blockchain, smart wallets are native to Starknet. So all the wallets in Starknet are smart wallets. So let me explain you what is a smart wallet. So a smart wallet will allow you much more feature than a regular wallet. It will allow you to sign a transaction with Touch ID, Face ID, execute multiple operations in a single transaction. So on Starknet, they are all smart wallets, and there is no external own accounts, so EOAs. So this is thanks to account abstraction. So let me dive into all of this information, because that's a lot of different information. But first, I will let you install Bravos on your browser as a browser extension. So let's do this together. Okay. Okay, so you can get your laptop if you have a RRL. Otherwise, if you are listening to this online, you can look for Bravos. So there is two wallet provider on Starknet. Bravos is one of them. So let's do this together. So you can download. I'm using Chrome. Okay. It's downloaded. Okay, so once you have downloaded Bravos, you can create a new wallet. I'm gonna do this with you. I'm gonna delete this wallet at the end of this session, so it doesn't matter so much, but choose a strong password. So now you have to save your recovery seed phrase. So I'm not going to flash it in front of you, even if I'm going to delete it, but please save your seed phrase. So I clicked, I saved mine, but I did not. Okay, so let's go. Okay, I skipped some things to make it more simple. Okay, and that's it. Now you have a Bravos wallet. Let me check. Okay, so now that you have a wallet, we will switch to Sepolia testnet. So here the wallet is on mainnet, as you can see here. So for the workshop, we're gonna go to Starknet Sepolia. Okay. So yes, this network is a network intended for testing. So you can use it to like try when you develop. It's nice to use Sepolia because you don't pay with actual money. So it's more like intended for testing purpose. Okay. Once you have your Starknet on Sepolia, you can copy your address. So your address is here, right above the name of your account. When you click, you copy it, and then you can go to the faucet. So you Starknet faucet, this link, you paste your accounts, request some circ. You mentioned that you are not a robot, and then you can send a request. Usually, why is it not working? Of course, it's not working. Pardon? Yes, let me double check that I was on Sepolia, because if I was not on Sepolia, yes, Sepolia, okay, should be good. Okay, Hmm. Okay. Let me know if you manage to get some token in the faucet. It usually works unless I'm doing it live. It never works. But maybe it's because I just tried this. Okay, not able to send request. Okay. Okay. I don't know. But I sent a request like in less than an hour ago, and usually you cannot send two requests, but it's a different address, so I thought it would be possible, but yeah, you cannot spam. So keep in mind that this money is not like free money, it's like testnet money, so it's not worth anything. So don't get hyped and request all the money from the faucet because you're not actually getting rich, you're getting rich on monopoly bills. Uh, So yes. Okay, so I'm gonna stop trying this. Okay, so let's continue with the session. I hope you managed to do it. If you don't manage to get any Stark through the faucet, you can send your address in the chat, and we will send you some Stark. So don't forget to send a Sepolia testnet address because I'm going to send you money on Sepolia. So you will, if you send a mainnet address, you will actually just receive nothing. So yes, you can send your address. Okay. Okay, let's continue. If you manage to get start from the faucet, congratulations, you are a warrior. Okay, so now we will be talking about complex interaction. So sometimes when you do an action, you have multiple steps. Like when you use an exchange, you might have to validate the token and then validate the swap. Like validate, okay, I allow the token and then I allow the swap. So that's multiple steps. It happens very often, and it can lead to some problem because maybe it's going to be in the same block, step one, then step two, but it can also be in the same block, but with some other transaction in the block put by the sequencer in between. Or it can even be in two different blocks. So this actually leave room for security hazards. You can have malicious attack that will actually be in between your steps, your transaction, and lead to some found loss. So that can happen, but it cannot happen thanks to multi-goal. So multi-goal is possible on Starknet. So multi-goal will be calling different smart contracts, so making different transactions in the same transaction. So they will be bundled, linked together, and you will be sure that the transaction will happen in the same block. So multi-call is actually also a feature enabled by account abstraction. So yes, so now you are sure that it's not going to be in different blocks, that it's going to be together one after the other, and you can be sure that those malicious things cannot happen to you. So yes, as I said, it's thanks to account abstraction. So what is account abstraction? So account abstraction is decoupling the signer from the account. So traditionally, the signer and the account are very much linked together. So the signer is your private key that is going to sign your transaction, and the account is going to be very, very basic, just holding your asset, not doing much. So in Starknet, you actually have the feature that every account is a smart contract. So you have a contract account that can be programmable and that can do much more than regular accounts that would not have account abstraction. So instead of just being an account that holds your funds, you can program anything in the account. So the account is a smart contract that can have any feature that you want to program in them. Yes, it can hold the assets, verify the signatures, execute multiple transactions using multiple. So it can do a lot of different things. So in practice, let's check what it can do. So for example, your signer could be your smartphone. So you will have the account contract, that is your account. It's a small contract, like here you have a small example of the minimum requirements for the account in Starknet. So you have an execute function that's going to execute the transaction, validate function that's going to validate that the signatures are valid. When you want to make a transaction, the signer will will sign the transaction, and the account contract will actually trigger a call to the smart contracts for you, and it can do whatever it's programmed to do. Okay, so now we will go back to an exercise. If you have any question, don't hesitate. Okay. So who in the room has Starks on their wallets on Sepolia Desktop? Just the people. Okay. Okay. Maybe we will leave this exercise for another session because most of you had the same bug with the faucets. So we will send some Sepolia Starks to everyone, but we don't have the time to do it now. So I will actually skip this. But the exercise was to interact with a smart contract, then check the transaction in the wallet and explore the account contract. So your account has a contract, and you can actually view it on the block scan and review like what are the functions that rule your account when you deploy an account on Bravos, like what functions actually exist in your Bravos account. Okay, so we will do this later. Let's continue. Okay. So now we will discuss about signature verification. So your account is going to verify the signature. So the signer sends a signature to, and the account can verify it. So you can verify your signature in different ways, and that enables feature like single signer, but also multiple signer. Hardware signer, social recovery. So social recovery could be you assign the responsibility of your wallet to your beloved and trusted friends or family, and then they together can help you recover your address. And then session keys, which I will cover that later, but basically with those features, you can have a better UX for the wallet, because now it's like you have your seed phrase, you have your private seed phrase. If you lose it, that's it. You lose your account. There is no way to differentiate you from the person who would, I don't know, steal your seed phrase, or if you lose it, we cannot know that this is your wallet. So that's actually this very, very bad UX for Web3, because most people are used to, you have a password, but don't worry, you can lose it. It's gonna be, we will find a way. We'll find a way to find your password. People lose their password on a monthly basis. and they can recover it. So having one private key, one seed phrase of 24 or 12 words, and if you lose it, you lose all your money. It's not a very good feature. So with account abstraction, smart wallets, you can enable different way of signing transaction than this just one big seed phrase that you cannot lose ever. And that's very good for any for this UX, for this particular UX problem. And then yeah, you also have the feature like session key which allow you to sign transaction in advance or sign transactions once and not having to sign multiple transactions all the time. So it enables different feature. You don't have to always sign everything every time there is the smallest thing to sign, which is a very good feature for gaming or other purposes. And then in the signature verification, Starknet actually supports multiple different elliptic curves. So that's more advanced, and you might be like, why do I need this information? So it enables Stark, it enables the Ethereum curve, but it's also enabling another one that I will talk about right now. So it's actually an elliptic curve that is used by your phone in the secure enclave. So in most of the modern phones, you have two systems. In your phone, you have a shared one. It has the operating system, it has the application, it has all the shared information. And then you have a secured one that contains your Touch ID information, your crypto keys. It has this hardware signer that signs for this specific elliptic curve that I mentioned. So it has secured properties, and we can use this hardware signer to make your phone into a hardware wallet because we support this elliptic curve in particular. So basically, you can use your phone to sign your transaction in a super secure way. So that's again thanks to account abstraction and smart contracts wallets. So yes, this system has different names depending on your operating system. Here are the names for the most famous ones. And then you also have it on your laptop. You also actually have secure enclave on your laptop. Okay, so we discussed about a lot of things for smart wallets, but basically, as a summary, why is it amazing? It has a much better UX than regular wallets. You can have much more flexibility. You can have much more option. You can have much more features. So some of the features we mentioned was multi-call, hardware signer, the social recovery, the session key. So all of that is enabled by account abstraction, which is decoupling the signer from the accounts. And yes, as I said, every Starknet wallet is a smart wallet. So you don't have just basic EOAs on Starknet. Okay. If anyone has a question about, yes. So you still have a private key, of course. It's just that it's decoupled from so you still have the signer, but your account is not just a basic account, it's a whole smart contract. But the smart contract can only execute transaction from your signer. So you still have the private key that will allow the transaction, but the transaction, the action that can do the accounts are much more complex than than the accounts on that are just simple EOAs. Okay, and now for the last slide of the day. So Starknet is the cheapest layer 2. So here you have some metrics. Maybe they are a bit old. I didn't update them. I mean, old in crypto is like 1 month old, which is so old. But okay, so maybe 1 month ago or something like that, it was those prices. So yes, Starknet transaction are super cheap. So as I mentioned, it's like a fraction of cent of a dollar. So it's not even like a cent. It's less than that. It's like a number that you look at and you're like, what's this number? It's so small, I cannot name it. So yes, that's the transaction, the fees. We will do a live demo, and you will see the fees. They are always super ridiculously low. And maybe I can challenge you sometimes to like say the number out loud and try to say like how much money it is. But it's very cool. So that's actually the price. It used to be a bit more expensive, but then there has been a protocol update that made it much cheaper. And so now it's ridiculously cheap. Okay.